So our presentation is about how we will be able to deliver features 10 times faster to our customers. And as you see here, we are from the Volvo doing the big vehicles, not passenger cars. That is another company. So my name is Svensson, and my colleague Johan Wranker. I am the one that don't have a compiler on the computer. Johan usually teases me for that, but he has. So what we want to cover today is the background to start with. Then we will come into the organization and technology and the remaining challenges that we still have. So this is what we have seen from the presenters before lunch as well. The software is growing in the automotive industry, and it's growing very much. It started in the 80s, and it's just continued to grow. And if this is a right linear growth, or if it is exponential growth, or however it looked like, that we can argue, but the growth is very big at least. And it's not only us at Volvo who has recognized this. There is a lot of investigations and reports and so on from a lot of management companies supporting or showing the same trends as we see in our daily life at Volvo as well. So this is really drivers that we need to master the software much better, but also that we have a lot of new competitors. And many of these competitors, they are originating from the Silicon Valley area, so they are more coming from the software industry. They don't have a mechanical heritage and so on that we have. That is an old automotive company. And of course, they have easier to adapt to a software flow and software way of working when you come from automotive and don't have so much legacy as the regular automotive companies. So that was the background. That should show that we really need to improve. We need to be more efficient, and we need to work with software in a different way. And at Volvo, we are addressing this by adding, changing our way of working. We are applying an agile development process for the product development, and we are using SAFe as a scaling framework for how we are implementing this. So far, we have around 15 trains, as it's called in the SAFe framework, up and running, and we have organized these trains under one lot solution. All of this is SAFe term, but I will not describe the detail of SAFe here today. We have a lot of different organizations involved, so this is not just one organization. It is a cross-organization set up within the different trains. But so far we have mainly focused on the software development, but we are starting to include the hardware development, electronics, and so on in the train and in this agile setup as well. So this is an ongoing journey that we are currently working on, and it is continuously growing. We are adding more and more part of our development within this framework. So to focus on the maximum delivery speed. To do that, we have organized our trains and teams into a setup that will give us the maximum speed. And to do that, we need to have a cross-competence teams and cross-competence trains. So we will have different competences working together in the daily life. And if we should be able to get the benefit of people working together in these cross-competence teams, we need also to have T-shaped people that can do more than one thing. Otherwise, it's just continue to with the handovers, but within a smaller team. So it's important that we have this T-shaping as well, so people can help each other in these cross-competence teams. And the teams and trains, they should also be responsible from the cradle to the grave. So they are responsible for their delivery from the early phases until the maintenance phase. So this is not any project setup that we create for a certain project and then we close it down. This is continuous operation that is done in this Agile setup and in the trains and teams. And then the work comes in from the trains, or from the projects. So the project adds things on the backlog to these continuous trains. To be able to reach optimal speed in the deliveries, it is important to focus on the feedback loop. The feedback loop, that is really how you can optimize the speed. And it is depending on how fast you can run this plan, do, check, act, or adjust loop. It is the speed of that loop that will drive how fast you can deliver new features to the customers. And one part of this optimization of a feedback loop is, of course, this organization we have with the cross-competence teams and trains. But if we only change the organization, we will not be able to have optimal speed. We also need to have the technologies in place and so on. So both organizational and technology changes are needed to be able to reach the optimal speed in the deliveries here. And by that, we will come into the technology area that Johan will cover.
Yes, it's time for the bits and bytes. Well, we talked about the plan, do, check, adjust. And that's the integration phase. And we do it, the goal is to do it on the vehicle level, obviously, because it's a vehicle that we are producing. So that is the goal, to be able to test that as often as possible. And a vehicle for us, that's the real vehicle with wheels, with a color, and so on. If we go down one level down to the system level, then we have removed the wheels. But we still have a color on it, because we still say that our central system creates this vehicle, break out this vehicle to set up all the interfaces. And you can test this both in a software in loop and hardware in loop setup. The same thing is on ECU levels. Usually we have ECU, sometimes we have two ECUs together, but there is an ECU level there. You can test that as software in loop, or you can test it with a proper ECU. And then on the SVC level, it's only software in the loop that we have as the test phase there. And then we have let's talk about the ECU level, how to generate the binaries. And now it's time for the binaries that are for hardware in the loop testing. So this is when we are building a large AutoSAR ECU in our environment, where I'm about to talk about a production release, so it's nothing special with it. Or all our releases are production releases. Let's put it that way. So, and we always build our releases on servers. So it's driven by Jenkins and it's pushed to a server. The triggering, starting a build, it's usually someone pushes some software, an update, or it could be manual as well. It starts off by a setup where Jenkins selects a server to run this on, because we have multiple servers, we don't know which one it is. It checks which tool that's present on the server. If it's not the right tools there, it installs the tools, and it downloads the software to build, and it downloads databases to use, and so on. That takes about 5 minutes. This is one of our larger ECU. So that's 5 minutes there. Then we generate the BSV, RT and BSV files. 17 seconds is the time it takes there to generate those files. and then we compile the software. It takes about 2 minutes. It's 800 files or something like that. Next step is to create diagnostic information. That is both for aftermarket and for our test tools to Cano, so it's generate the PDX files and that stuff. But consider it's for the aftermarket as well. I have no problem with this release being on the road for the next 10 years. That's the setup. That's what we are building. We download the software into an ECU just to make sure that the build is okay. Now, this stage is just okay. We have testing later on to see that it has the right functionality. Now, I just want to make sure that we don't break the test environment later on. So this is download it, run a few tests. 6 tests is usually the setup here. And then run a number of static checks as well to see that we have the right setup, MISRA tests and so on. And then we do a release of this software. We push it into our Artifactory system where it can be stored for the next 10 years. So we have full control over it. I don't know how many of you who's been generating software, but using to generate the RT and BSV software using DaVinci Configurator or Genie or EAD in 17 seconds. I hope a few of you were a bit surprised, because it actually takes 15 minutes to generate it. But what we're doing is if I generate the software on a server somewhere, the Gradle checks, it combines all the input files and says, these input files produces this output file. By doing that transformation, it knows that these input files produce that output files, and it stores that in our cloud. So the next build trying to generate with that set of input files, then it just gets the cache from the cloud. Therefore, it takes 17 seconds here. It's half the time, the build time here, which we eliminated using Gradle cache. So that is a real game changer for us, because you don't have to wait for that. And then, obviously, within the next 6 months, we will decrease this time with half. So that's about it. That's what we are aiming for right now. This is a pure waterfall integration. That's what we have done for a number of years. Do the software in the loop integrations of the SVCs. Do that for a number of weeks. Then the time comes with the code freeze. Then you throw it over the wall to the next department. And they do the ECU integration. And usually come back with something is wrong. So you have to do it twice. And then the time comes when the ECU is supposed to be delivered. So you throw it over the wall to the next department, which does the vehicle integration there. And those guys usually don't even have time to do a redelivery. So it's just red flag, something is wrong here. Can we live with it? Can't we live with it? And then do the release. We have managed to come to this situation right now. So we actually run the software in the loops, the ECU on the hardware integrations and the system integrations continuously all the time. So we don't do it fast right now, but we do it more controlled. And then we have a few ECUs which aren't there yet. They are delivered to us. So there is a final integration there on the system level and the release. You see the date 2017. There we had the old flow where we had specification for 8 weeks. We had the implementation for 8 weeks, and then verification for 8 weeks, and then you got the feedback. It's 48 weeks. You can actually do the specification, take a vacation for 16 weeks, then come back and get your feedback. It's 48 weeks feedback cycle in in worst case there. With the Agile setup, we are on 10-week cycle here. That is what the organization change has made. Now we are on 10 weeks. That's really good. But when all the stars align, when everything is fine, we do actually reach 1 day right now. And we are really, really pleased with that.
For some issues already today.
Yeah, for some issues today. So Jens, aren't we just pleased with this?
We are, but of course, still some challenges remaining, as always. So this is some of the challenges that we want to highlight, because this is not only things that can affect ourselves within Volvo. It also we need the full support from the complete automotive domain to be able to meet these new players from Silicon Valley and so on. So the first statement here that the automotive domain are changing too slow. Do you know how many years it is between these two phones? It's 10 years. And how much do we usually change within automotive in 10 years? Not so much. So just a reality check to see how fast things are happening, and that we really need to be on our toes to be able to meet the future. And we see a problem with both the tier ones, but also, of course, our internal structure with purchasing and so on, that we tend to still focus on ECUs, and when we buy an ECU, then we need to specify up front, and it doesn't really fly in the Agile setup. So this is really a change that we need to be able to complete, so we can work differently with the suppliers and our purchasing organization. Then we have some challenges with the tool chain. Johan mentioned, or you saw before, that it takes 15 minutes, and that is doubling the time to do this ECU build, just because we have to do the RTE generation. So what we see is that adaptive AutoSAR, that is really a good step in the right direction to support an agile way of working and so on. We have not started to use adaptive yet. We are looking into it, but also adaptive is in an early phase, and we haven't really seen any proof of tool chain and how efficient the tool chain will be around adaptive AutoSAR. But the tool chain are really critical if adaptive AutoSAR should be a success, and if it should support us to work as fast as we want. When it comes to classic AutoSAR, it doesn't really support this from an architectural point of view, as it is built on that we should optimize on memory and CPU performance and build complete ECU binary more or less for every change in the application layer. But even if architecture doesn't support it, it's important that we have an efficient tool chain, because then we can automate more and more of these different steps in the ECU integration. So the tool chain can really reduce the problem, even if it doesn't solve all of the problems. And of course, we have internally just focused on the product development part so far. So we don't really have an agile business operation yet. Then we need to involve a higher level of management to be able to get the input from product planning and from the brand and business side, and also all the way to the aftermarket and our production facilities and so on, to be able to handle the software as often as we can deliver it. So we have a lot of steps to do internally as well. It's not only externally. But we also have some tool challenges.
Yes. Let's see it. Let's face it. Cloud is part of our daily work right now. It should be. So tool developers who don't see the license model for cloud, it should embrace it. Not just, it's an add-on to have it in the cloud. It can't work a few years from now. Click next to install. That works if I have one computer, if I have 3 computers. But if I don't even know the name of my computers, if I spawn a new computer every day, then I can't have click next to install. Remove that. The same thing is for operations. It should be possible to run operations, all operations, command line based. So to run it headless. And then just add a GUI afterwards. If someone needs it. Because the developers right now at Volvo, they usually don't start the GUI if they can avoid it, because it takes too long time to start. They write in the files directly. And last point there, tool speed. It should be depending on the hardware. I want to be able to say that, oh, we can generate the adaptive outsole within a minute. Just buy the right hardware. With our classic stack right now, there is no hardware out there which makes it possible to build within a minute. Because it's not built to do that. Yes, thanks for that. We had some positive ways and something to bring on for the future.